Assalamu alaikum, everyone. Thank you again for your time to attend the Cloud Penetration Testing webinar, which is presented by NetSPI and SecureLink. SecureLink is a risk advisory firm headquartered in Dubai, UAE. We are an independent advisory assessing our customer in identifying and mitigating and managing their business risk. We provide a comprehensive assessment of risk across people, processes, and technology, and help put the right governance framework in place to ensure that the risks are continuously monitored and acted upon. We are covering three pillars for security: people, processes, and technology. In people, we are providing security awareness, customized security awareness. We are doing ethical hacking, phishing, smishing, all of these. Regarding processes, we are covering implementation of any regulation and frameworks, also creating business processes and procedures. Also, we are covering data classification, personal data protection requirement, helping organization to implement these frameworks. In addition to that, we are covering in technology, assessing the technology security, application security, penetration test, and as a part of technology, we are providing penetration test by NetSPI. We have Sam with us. Sam is the director of EMEA services and leads NetSPI EMEA penetration testing team. Sam, as a penetration tester and a cybersecurity consultant, focuses on translating complex technical issue into risks that business can easily understand. With his core areas of expertise covering web application infrastructure and cloud security. Also, when he is not testing existing security controls, Sam help to shape the strategy for the implementation as a security architect. This knowledge is used to help upward the range of the organization to improve their security posture, ranging from small family businesses to multinational corporations, banks, and national government. Sam, I would like to hand it over the mic to you to lead this webinar. And I would like to highlight for the attendees, if you have any questions, please feel free to send it on chat box or question and answer box. And we will happy to answer these questions at the end of the session.
Thank you very much, Ahmad.
You're welcome.
And a very warm welcome to everybody that's joined us today. It's great to have you with us. I hope this conversation today will be a useful insight into the world of cloud security, the way that we conduct our security testing, and help you to plan for what you need to do next when it comes to protecting your organizations from those that wish to do you harm. So with that in mind, I'm going to start with an overview of why this conversation matters. Why does cloud security really matter to us? And there's a few different reasons for that. Many of them we're all familiar with, but there are some that really stand out to us at NetSPI and our security testing team. And that big one is that the cloud doesn't operate in isolation. When we talk about the cloud, we're talking about data centers full of computer systems, often managed by massive organizations, likes of Microsoft, Amazon, Google, that kind of thing. And despite that scale, there's still an intrinsic connection into the fabric of all of the organizations that we work with. There are some businesses today, many in fact, that have a lot of on-premises assets. That's your servers and your laptops, your mobile phones, things that people hold and use to do their job. There are other companies that are entirely cloud native. They may have laptops and phones, but all of their servers and complex infrastructure is entirely in the cloud. But there are no businesses out there that don't have a dependency on the security of the cloud, on all of those things working together successfully and avoiding somebody being able to compromise them and do some harm. So one of the things that we're trying to achieve at NetSPI is to help communicate what the risks really look like. How do attackers do some damage? And of course, how you can actually prevent it. And one of the worst scenarios that we've seen, and we'll talk a little bit more about this today, is a scenario where attackers have targeted the cloud from anywhere in the world. It's on the internet. And they've used the cloud to get down into your physical assets, the systems that are next to you right now in the office, wherever you are. That's due to the relationship between the infrastructure we depend on that's next to us and the way it's integrated increasingly so with the cloud. And we will cover that in a little bit more detail as we go forward here. So let's have a look at today's agenda. We'll start with a little bit of trend analysis. This gives you a little bit of background on what we've seen over the last few years, in particular the last specific year, in terms of things that we've seen that are problems in the cloud and, of course, what we can do about that. It comes under remediation. And then we've got the methodology that we use to work with as well. Our pen testing that we conduct in the cloud space isn't just a checklist. It's not a configuration review where we just look at a few settings and tell you whether they're good or they're bad. There's a lot more depth that we go into at NetSPI. In fact, we've written an entire book that's hundreds of pages long on just testing the Azure cloud, or Azure cloud, as you might know it, Microsoft cloud. And we're working on the next features for things like AWS and Google Cloud as well. I'll blend into that some real world examples so you can see what attackers are really doing and what you need to look out for. And then we'll end with some question and answer time, as often there are some things that are unfamiliar or extra details that you might like that we can have a conversation around too. So let's start with our vulnerability trends here. This is something that we've compiled together at NetSPI based on the thousands of hours of testing that we conduct every single year. This covers the various different services that we offer. And in this case, you can see that we've gone from the very common exercises that are performed by many organizations today, things like their web application testing, their internal and external network testing. But for this year, we've been able to include the cloud as well. And there are some interesting takeaways from this particular graph. So if we take a look at the blend of colors here, you can see that on the far left-hand side, the reds here are just informational issues. And the far right-hand side, we've got the yellow and the light blue, which represents the really dangerous stuff, the high risk, the critical issues. What I think is interesting here is the cloud has got fewer of both the critical issues at the very top and the high issues for the most part, but it's also got fewer of the informational issues as well. By far and away, what we see are things that you would class as medium risk issues in the cloud world, which is a little strange when you think about it because of what I've just described around attackers being able to come into the cloud and then demonstrate that they can attack entire organizations from there. But the reason that we're seeing this pattern is the cloud is not an easy target for attackers. If you compare that to a few years ago, maybe quite a few years ago, if you created a website or some kind of web API, perhaps, maybe even you're just hosting some kind of service that's internal to your network on an older operating system, maybe Windows XP or even earlier than that. Those systems, if they're running outdated software and they're not adequately protected, they can be quite easy for attackers to exploit. One of the most famous examples in the world is the WannaCry ransomware. We had that attack us here in the United Kingdom and it hit our National Health Service quite badly. The reason that it was so effective is because the exploit it used to compromise systems was so simple. It effectively was a couple of buttons on a keyboard, a couple of clicks, and you could have completely unlimited control of that particular system. And you could do that again and again to hundreds, if not thousands of systems. That's fortunately less common today, but still a very real risk if you're managing your own servers, your own systems, your own applications. But the cloud tends to be a little different. You can, of course, run your own infrastructure. You can run virtual machines, you can run applications, but it's quite common that you'll use software as a service or platform as a service offerings. By design, they abstract away all of the need to look after things like operating systems and the low-level details. And as a result, it's quite difficult for a vulnerability to exist that's really dangerous. That's the responsibility of companies like Microsoft and Amazon to look out for. However, it is also very easy to click the wrong button, as it were, in some of the cloud management portals. And I will show you an example of just how easy it is to think you're doing something in a secure way using the portals for cloud providers. And actually, it turns out it's a very dangerous way of handling and building your infrastructure. So what we tend to see are a fairly large number of medium risk issues that are combined together by attackers. And using that combination of 1, 2, 3, or even more medium risk issues that look not particularly dangerous in isolation, they are then able to demonstrate a serious impact on your organization. So it's worth highlighting that when we're talking about cloud attacks and what attackers really do, there are some commonalities between what we do in the cloud and what we do in traditional pen testing, or indeed what attackers do in traditional attacks. One way or another, in theory, your attacker is going to be outside your organization. There is, of course, the risk of insider threats too, which should never be ignored. But generally speaking, attackers are outside of your secure zone. They don't have access to your systems or your devices when they start their attack. So their first step is always going to be some kind of initial access. The most common paths for that remain things like phishing attacks and malware. But the cloud does open up a few more possibilities, and I'll cover some of those too. The most common of which is publicly exposed assets that were never intended to be publicly exposed. We're then having to look at the same attack path of lateral movement and privilege escalation, which in simple terms means the attackers will attack one of your systems, and then they'll aim to attack others too, see if they can get more of an impact, more access to your organization. Privilege escalation means going from limited access, maybe a normal user, all the way up to an administrator or someone with much broader access to sensitive data and systems as well. All of those activities are designed to give the attackers more power, particularly with attacks that involve things like ransomware, where they want to attack as many systems as possible and to be able to remove as many of the blockers that stand in their way. The final part, again, is very common. Persistence is the name given to attackers maintaining access to your environment and to your organization, even after you've managed to detect them. And even if you haven't detected them, they tend to want to hold on to that access for a significant period of time, sometimes even to attack you multiple times in a row, if they believe that that's going to result in more money at the end of their attack. Persistence has some interesting details when it comes to the cloud, and we can touch on those a little bit later as well. So let's take a look at the most common issue in the cloud. This is one that you'll have seen before, and I rest assured there are some more exciting details in this webinar today. But it's important that we focus on this at least briefly, because it is so unbelievably common even today. On Amazon, Google, and Microsoft's Azure platform, there is the ability to host data in a way that is accessible from the internet. That is a critically important part of using the cloud. You need to be able to put your business data there, but also retrieve it for whatever business purpose that you've got. The problem is, particularly for those that have never used the cloud before, who are less familiar with how to secure it, it's very common for people to put things onto the cloud, various bits of data, and not provide adequate security around it. And often the expectation is that if you've put a file somewhere in an S3 bucket on AWS or an Azure blob, if we're talking about Microsoft platform, you'll expect that nobody's going to find it, because how would they know that it's there? And that's the key detail that many people miss. This isn't a game of people who have malicious intentions going into their web browser and just typing in the names of random files. I'm sure you know that, but it's worth knowing how important, how obvious it is that there are tools that do this automatically. And we have some of those right here at NetSPI. We're able to enumerate, that is, automatically look for files all across the internet and identify them pretty frequently that shouldn't be on the internet. And the only thing that's making it difficult to find those is the ability to guess file names, or perhaps even to find an index list of those files. But time and again, even today, we continue to find data that's accessible if only you know where to look. The consequence of that can be pretty serious too. It was only a few months ago that we came across an entire SQL database full of credit card information, so payment card information for all of your customers. And in this case, it wasn't the database that was the risk. It was a backup file of the database. So clearly there had been some good security thinking going on when they designed the architecture of this application. This particular company had made sure their database, you couldn't reach that from the internet. The application was behind certain restrictions. All of that was great. But somebody along the way had said, well, we should make sure we back up our database. We would not want that data to be lost if we have some kind of failure or indeed an incident in some way. But that backup data was pushed straight into an S3 bucket on Amazon's AWS platform, and there wasn't any security around it. So eventually, over time, that was actually picked up by Google's search engine. So if you knew the right thing to search for in Google, you would actually get a direct link to the backup of this database right there. It didn't require any fancy tools. It just needed you to know what to search in Google. That's how easy it can be for people to come across this data if things go really wrong. And unfortunately, it did in that case. Now, there are some really good mitigations that you can apply when it comes to this kind of thing. AWS have got a particularly strong example where they will have, when you create an S3 bucket to put data in, they have a very clear section that says, would you like to block public access? And it lists a few different checkboxes. It's a simple tick the box to block all forms of public access. And that includes attempts to give public access to that data using specific policies or changes in the future. As long as you've ticked the box, you have blocked public access. And the only way to override that is to untick that box specifically with all the warnings that come with that. Now, that's great in principle, but what we're often seeing is that people aren't enabling that because they expect that in the future, they might need some level of public access to that data. Or sometimes they may not understand, well, if I block public access, how do I actually access this data from a system that is nothing to do with AWS? Maybe it's a laptop on my desk and I need to be able to access S3 data, but I only want to do it temporarily. Maybe I'll just enable public access. It's so much easier. And as a result, those boxes are often staying unticked. So if there's one takeaway from this particular risk, it's to start from the premise that security is the default. So in your scenario where you're needing to host some data in the cloud, tick that box to block all public access, and then wait until you finally have the conversation where you say, I need access to this data and I cannot find a way to do it using some kind of credential. Could be keys. AWS and all the cloud platforms provide static keys that you can use, but there are some more advanced mechanisms like links that can be signed using a time-based signature. It means you can send somebody a link anywhere in the world and they'll be able to access that data, but only temporarily, which in many cases provides a perfectly reasonable way to access that data, but the access expires automatically. You don't have to worry about it being permanently public or giving somebody keys that never expire. So start from the default of a secure, locked down environment, and then let your business requirements and your needs remove components of security where necessary. It's better to do things that way from a security point of view than to leave things open just to make things easier, because you might end up, without realizing it, creating yourself a very, very busy period when you're dealing with a security incident in the future. Now, we also see a similar pattern with IAM permissions. IAM stands for Identity and Access Management. It's a concept that's existed for a long time in the world of computing and IT, but in the world of the cloud, identity and access management forms the foundation of almost all of the security across every platform. So in this case, we're going to talk about this at a fairly high level using the example of a taxi driver and their taxi. So in this case, a normal scenario, if you are a taxi driver, you will have one key to one taxi, and that is the way that things should be. You'll only need to drive your taxi. However, it's entirely possible that you could issue a taxi driver with multiple keys. So let's say that you run a taxi company and you have many drivers and many vehicles. You could, if you wanted to, issue every single driver with a key to every single vehicle. And if you did that, it would mean you wouldn't have to worry about keys anymore. You could just tell any driver to get into any car, and you wouldn't need to go out of your way to find the right key for the right vehicle and record who's got it. And if you wanted, you could even give the driver a key to your own personal car just to make sure that they can go and collect items from the shop whenever you need them to. But I think you can already see just from your own instincts that giving somebody the keys to loads of different vehicles doesn't feel like the best way to go. Ultimately, that's fine as long as the taxi driver is someone trustworthy. But what happens if somebody not trustworthy manages to get hold of those keys? In this case, you'd hope that you're only going to provide a key for a specific vehicle. But if you don't do that, you'll end up in a scenario where one taxi driver who is either compromised, let's say in the world of IT, somebody's stolen their particular password or keys in the case of the cloud, and they are then able to go and steal any of those vehicles, including your own, and run off with them, which is completely impractical and unsafe from a security point of view. But it works from a business point of view. In fact, if I go back to here, this functionally allows you to operate as a business. As long as nobody does anything malicious, as long as nobody tries to steal anything, then this doesn't cause a problem. The problem only exists when things go wrong. And that's why we see it so often, is because people can genuinely say, we've been doing it this way for 1 year or 2 years or 3 years, and there hasn't been a problem. Because up until that point, they haven't had somebody whose identity or credentials has been stolen, and they've got access to all of these different things. So the key thing is to determine the scope of what you need access to. You have some kind of broker in the middle who's able to tell you, okay, I have verified your identity and I know that you need access to only this particular system. Now that's great because you're doing the minimum level of access that you need to give that person. It means that if that, in this case, taxi driver is compromised or impersonated, you're only going to lose one car. Or in the case of IT, if that one developer or user is compromised, you're only going to lose or have compromised the data that they can access. You're going to limit the impact of that particular attack, which makes it much easier to recover from, limits the impact on your organization, your reputation, even the cost associated with a security breach. All of that is made better by taking the time to decide, what does this person need access to? And you can actually go further too, which is what this slide is all about. Cloud platforms are increasingly offering just-in-time or JIT access, which is a really powerful way of providing people with the access that they need. And you can do this for everyone in your organization if you wish to. So what this means is instead of saying you are an administrator, you need all of these permissions all of the time to be able to do your job, we can set things up so that you are providing that administrator with the access they need specifically when they need it. And it's signed off by somebody else, in this case, a person behind a different desk. So if, for example, I needed to access a particular server in the environment and I was an administrator, traditionally, I could just log in. I could enter my username and my password and I'd have all the access I needed. But that means if I was compromised and an attacker managed to get my username and password, they could do the same. And there would be nothing there to stop them or check that it was a legitimate reason to be accessing it. If we use just-in-time access, I would have to ask my colleague a simple message through Teams or any other platform that you use to say, hey, I need access to this system, here's why, and I'll only need access for about an hour. Then you've got another colleague in your team that can verify that that is the real person, confirm that the reason they're accessing that system is legitimate and justified, and only then does that administrator get the access that they need. Better still, it's time limited as well. So as soon as they've done the job that they need to, they can carry on with the rest of their working day, and that access key or token or even temporary credentials will expire, and that session will expire too. The end result of that is that in a worst case scenario where an administrator is compromised, an attacker is going to immediately start looking for opportunities to move laterally, identify other targets. What can I do with the access that this person has? And the answer is going to be almost nothing. Almost nothing until the attacker is willing to send messages to people to try and convince them that they really need to access this system. They might even manage that on 1 or 2 systems, but there's no way that anybody in their right mind is going to approve an administrator accessing every single system all at once, which is generally what we see in ransomware attacks. So implementing just-in-time access, like what we've got here with time limits as well and independent approval, is made very easy in the cloud by the various platforms that exist. The most commonly used one is the Azure platform from Microsoft. They call it Privileged Access Management, or PAM. It operates just like I've described. You can set things up so that people can request certain permissions and somebody else has to approve them. It's just a couple of button presses and maybe a conversation if needed to verify things, but it doesn't add much effort to the workflow, but it does add a huge amount of security there as well. It also mitigates our next problem here, which is clear text credential storage. And we have got a story all about this as well, which I'll come on to. Clear text credentials exist all over the cloud, kind of. There's an important caveat here, which is that in many places where you can put credentials, they will have a degree of encryption over them. A good example is Azure Functions, and I'll talk more about this shortly, where when you enter credentials, they are encrypted by Microsoft, but they can also be very easily decrypted back to clear text. So to all intents and purposes, as far as we care as attackers and pen testers, to us, it looks like clear text, and that's what counts. So when you're configuring the cloud, one of the most common things to do is to give one section of your cloud environment access to another service or piece of data in the cloud. That might be an AWS Lambda function that runs your code and it needs to access a SQL database in another part of the cloud, or maybe even a whole other cloud provider. To do that, you'll need that Lambda function to have credentials or some kind of permission to access that other service. There are different ways of doing that, but one of the most common ways that people do it is just put static strings of text directly into their source code, or maybe even directly into environment variables of their cloud environment. That's just done through the web interface. The problem with that approach is that it's very easy for somebody with very limited permissions, just the ability to read information, they can't even edit or modify things, to read those clear text credentials and start doing some damage with them. So instead, it's a fairly easy thing to do, but only once you know about it. If you need to handle static secrets, strings of text that only certain people should see or only certain systems should be using, do make use of some kind of secrets manager or key vault. All of the major cloud platforms provide them, and they allow you to integrate them directly into their services. So something like an AWS Lambda function can be the only component of your cloud platform that is allowed to request the value of that secret. And it isn't in the source code. So your developers can handle the code. You can share that with whoever you need to. It could even be open source. But the secret is only accessible when that code is run in that Lambda function in your cloud environment, which makes it massively more difficult for an attacker to be able to pull that secret out. Not impossible, but significantly more difficult. And they would almost certainly need more access than just read access at that point. They need the ability to manipulate the code itself, or perhaps find a flaw in the code that they could attack. It makes things much more difficult, and that's ultimately what we're aiming to achieve here. Now, I've mentioned a few different companies. I mentioned Microsoft, Amazon, Google. There are others too, but it's important to understand this concept, which in this case is the shared responsibility model. And I'll come on to the vulnerable software and the OS versions and the patches side of things in just a moment. But what we've got on screen is a representation of shared responsibility, and it changes depending on how you use the cloud. So on the far left-hand side, your on-premises assets, that's your computers and servers and systems in your offices on your desk. You are responsible for everything about security there, all the way from the physical security of keeping that device from being taken away to the application security at the top, where you've got the right code and it's configured to run in a secure way. But as you start to use more and more in the way of cloud services, all the way towards software as a service, where you just upload your data and there's already an application built, platform as a service would be something like a Lambda function where you provide the code, but you don't have to provide a server. And then infrastructure as a service, that next one along that's close to on-premises, would be virtual machines, which we'll talk about in a moment. You can see how the responsibilities for security shift. So depending on your resources, your budget constraints, as well as your people constraints, you can leverage the cloud to start shifting the responsibility for security onto a cloud provider instead. Which means if you've got a small security team, or you feel like keeping on top of security is a difficult thing to do, consider making more use of platform and software as a service. It's important to remember, though, that there is no way you can completely remove the need to monitor and manage security. Even in the platform as a service world, things like your application and your identity and access management will still need you to manage and consider those. But what you can do is remove the need to care about things like the operating system and patching and physical security in exchange for paying a cloud service provider to do that for you. One of the most common examples of what we see companies choose to do this for and why they shift to the cloud is the classic case of vulnerable software and operating system versions. Those bits of vulnerable software are exactly what we look for as attackers. And that's exactly what was used to attack the United Kingdom a few years ago in our health service, because we had outdated systems. They happen to be running on premises in hospitals, but the same risk can exist in the cloud too. It's particularly common for it to exist where you've got all of your infrastructure moved directly up to the cloud. It's not been redesigned to use the cloud. It's simply had all of your servers and compute systems moved to be virtual machines in a cloud environment. You might have even brought technical issues and vulnerabilities with you as you migrated to the cloud, depending on how you did it. And ultimately, that means when you've brought an old design, you've brought the same risks. To a degree, it doesn't really matter whether, as an attacker, you're external or internal. If I can talk to a vulnerable system, I can still attack it. So by far and away, the most important thing to do here is think about, is a virtual machine the right way to go? But if it is, you'll still need to do your patching. And it's really important that you don't lose visibility of that. Just because it's in the cloud and it's not a system that's part of your on-premises environment, you may not be vulnerability scanning it, depending on how your setup is. Don't lose sight of patching. It being in the cloud doesn't inherently make it safer. That only happens if you do things like network isolation and, of course, the patching and update checks. The good news is that a lot of the cloud providers will provide a lot of those services for you. They'll be able to give you a platform that will monitor all your systems and say, hey, this system's missing this update. They might even provide the ability to automatically provide those updates too, so you don't have to do much in the way of manual management, which is ideal. So I'll take a step back now from some of the high-level stuff, and we can have a look at the methodology that we use here at NetSPI. We are a little bit different to our competitors in this space. The reason that we're different is that we start with a configuration review, but that is only the start of the way that we operate. So we start by analyzing what you have. What resources do you have in the cloud? How are they configured? Are they configured in a sensible way? But that is only as a part of a reconnaissance process, because the next thing that we'll then do is split out into looking at what we can see from the internet, routes that we might be able to take into your cloud environment, your applications and your data. And then, assuming that it's something that you're interested in, we'll also have a look from inside the environment. What happens if somebody managed to compromise a system inside the cloud? Maybe you had a malicious insider who, for whatever reason, decided to sell their credentials to somebody who wants to hack your organization. What damage could they do? So instead of it just being a review of the buttons and switches and settings in the dashboard of your cloud environment, this is actual pen testers, real hackers who will connect to systems and see what they can connect to yet. And I'll show you an example of that on our next slide as well as we go through a bit of a story. The key thing is we're not just looking for config flaws, we're looking for full-blown misconfigurations. And most importantly, we're looking to demonstrate what they could do for your organization. So speaking of demonstrating, we'll move on to exactly that right now with an Azure war story. So this is Microsoft's cloud platform and one of our customers who we worked with not too long ago. This particular customer was using an automation account. This is a mechanism that Microsoft offer as part of their cloud platform to automate all sorts of IT processes. This could be for bringing on board new staff to your organization, could be managing updates like we just discussed, could be just about anything that you need it to be, and it can be managed in the cloud just by scripting and automating all the steps in that particular process. So it's a very powerful platform, which offers a lot of benefits to an organization by saving costs. Instead of asking your staff to manually do complex processes, also removes the chance for error too. So it's clearly a useful thing to leverage, and that's exactly why our customer was doing that. But just like I described earlier on, for a system to be able to automatically do whatever job you assign it, there's a very good chance it's going to need some credentials to speak to other systems that are involved in the process and be able to establish some kind of trust with those other systems. That is supported by automation accounts. In fact, it's so very well supported that you can go to the menu, as you can see on the screen here, and you can click the credentials button and you can enter credentials. It's all built into the workflow of creating an automation account and the automated process you're designing. That's also encrypted on top of that. So anything that you enter in there, Microsoft Confirm is encrypted when it's stored on Microsoft servers, so that if anybody stole that data directly, they would only have meaningless data. The problem is those credentials have to be reversible. This account that you're using needs to be able to pull those credentials back out and then provide those credentials to whatever other system that it's talking to. And what that means in reality is that you can go and reverse that encrypted credential. So what we were able to demonstrate in this particular case is that with just limited access to this customer's cloud environment, we had contributor access, which means we weren't an administrator, we didn't have loads of power to see and edit things. We just had the limited ability to look at a few components of their cloud environment, equivalent to maybe a technical user, but certainly not an administrator. With that limited access, we couldn't do crazy things like spin up virtual machines for cryptocurrency mining or deploy ransomware across the organization. It seemed fairly restrictive. It seemed fairly safe. However, with that limited contributor access, we were able to edit the code of this particular automation just a little bit, just by a very small amount. In fact, all we really did is add this command that I've got on screen, get automation PS credential. That command will take the credentials that you've given the automation account and it will decrypt them for you and provide them. Now, usually you would use that command to pull the credentials and then you would use it to immediately pass those credentials to the next service that needs them. And then you'd scrub them out of the memory of that particular process and you carry on. But what we did is simply print the credentials out to the console. So with a single line of code added to this particular bit of automation, code that did nothing to the actual automation, it was still functioning perfectly fine. There were no errors, there were no issues. We were able to see the username and the password that this automation used to do all of the different tasks it performed. When we investigated a little bit more about what those credentials gave us, it turns out they were Intune administrator credentials. Some of you may well have heard of Intune. For those that haven't, it's a Microsoft platform for device management, commonly used to provide secure device management for all of the laptops, potentially mobile phones, sometimes even servers and central systems across an organization. Intune has the ability to do some very dangerous stuff in the wrong hands, and this particular automation system was given total administrator power across all of Intune. It wasn't limited, it was very much unlimited. So what this actually meant is we'd gone from a contributor to a specific automation account, so very limited access, all the way to an administrator of all of the endpoint devices in this organization. So to put that in perspective, that meant that we could run our own PowerShell code across all of these different systems, unrestricted, every single laptop in the organization. And to put that in context, we've seen this being done. The ALF-V or ALF-5, depending on how you would refer to them, have been using this particular technique to be able to pull down ransomware from an S3 bucket, just like we were talking about earlier, and execute that on systems. The scripts that they deployed with PowerShell via things like Intune disabled a bunch of the controls that were also there to protect systems. Intune is so powerful that it doesn't just allow attackers to control things, it allows them to disable your security. So it's extremely important that that's kept safe. And doing that is pretty easy to do, fortunately. In this case, there was no need for specific credentials to be in that account. You didn't need to give some specific credentials global Intune administrator permissions. Instead, they should have been using managed identities. For those of you that have managed on-premises environments, Active Directory offers service accounts, managed service accounts. This is the same idea in Azure, and you can see the same in AWS and Google. It's all very similar. In the cloud, try wherever you can to use managed identities or attach roles to services. Wherever you can, avoid using static credentials that are readable and writable by people. What this means is you can give this automation account exactly the access it needs. So instead of global Intune administrator, give it ability to reset passwords, but that's all it can do. And you can attach that permission to the identity of the function, which means I can change the code, but there's no credentials for me to pull out at that point. I can't then take those credentials and use them on a totally separate computer for a totally different purpose. The permission is intrinsically linked to the service that you're using. They can't be separated. They can't be stolen. Now, I'm sure that time is going on, so I'll keep this one fairly light. We just wanted to share another one with you around AWS. A similar scenario around the misuse of permissions, generally down to the misunderstanding. So here's an Elastic Container Service. This is a way of running things like Docker containers without having to host your own servers. You just provide a template for your code and your container, and Amazon will be able to handle the rest for you as part of their AWS platform. For them to be able to do that, you need to provide a definition. It's a file that states, here's what my application is, here's the permissions, the IAM role that I'd like you to use, here's how I want you to launch my app, and some other data as well. Part of that is that you'll need to provide the access information that this application needs, and of course set up the permissions so it actually has those permissions to operate. And this particular customer had set up these two permissions, which seems fairly simple. EC2 run instances means the ability to run virtual machines in AWS. For their particular application, that's what they needed. That makes sense. But IAM pass role is a little bit stranger and actually really quite dangerous, as I'll show you now. IAM pass role doesn't give you any implicit permissions to do anything, but it effectively gives you unlimited permissions the way that they've set this up. So in this particular case, pass role allows somebody to assign permissions to other resources. So if you had the pass role permission, you wouldn't be able to give yourself permissions. You couldn't make yourself an administrator, and that seems fine. But if you have the ability to create EC2 instances, create virtual machines, and you can pass roles to other people, you just can't do it to yourself, then it turns out you can now pass permissions to a system that you create. And that's exactly what we're able to demonstrate. So even though our permissions were limited to just pass role and EC2, and this application's permissions were the same, what we could do is create a virtual machine of our own using that permission, and then use the other permission to give that other system administrator power across the whole of AWS, that particular customer's account. Using that system, we could then just log onto it. We created that virtual machine, so we had the username and the password for it. We then logged onto that machine, and we could use that machine's credentials to be an administrator, which meant we had gone all the way from a read-only user that could just see the configuration of this application to a full-blown AWS administrator with access to everything that that organization was hosting in their cloud environment. Read-only access can still be dangerous if certain things are architected in the wrong way. So I think this was a particularly valuable lesson for the customer that we worked with. Their issue ultimately was that they had some of those credentials in the task definition that I mentioned at the start of this particular flow. Their configuration was detailed and complex. They thought about a lot of components, but what they hadn't thought about was their keys were just stuck in their configuration file. And in theory, that config file was only going to be accessed by people that had access to the app, but we didn't need to have access to the app. We just needed to have access to the configuration to read it. We had no power to edit or do anything worse, but reading it alone was enough to be dangerous. Not to mention that pass role was already more than they really needed in that case. They could have preset up permissions and then assigned a preset role to all the systems they created, which is what they now do today. Ultimately, that means don't store static keys, use those managed identities, just like I mentioned, and also make sure you're using the least amount of permissions that you can. Same principles apply in the cloud as they do on your other environments as well. So just before we get to the point of summarizing and then a few questions and answers, I do want to emphasize us a little bit more as a company and as a team, and how we can help you if you would like some assistance with securing your cloud environments, whether it's cloud environments that already exist or plans for the future. The reason that we have got to the position that we are in as a company is because of the quality and the research that we deliver both to our colleagues and to our customers. Our entire focus at NetSPI is quality, and we take the time to conduct research to make sure that we are at the forefront of understanding cloud security. In fact, we're so close to the front of this that we have a publicly recognized relationship with the likes of Microsoft, and there are a few other companies that we haven't got public relationships with, but you can make some guesses. We're able to use those relationships to be at the forefront of new vulnerability discovery. I think right now, as we speak, one of my team here in the UK has found an issue in one of the cloud platforms that we're in conversations with, something that we've been conducting research on for a while, and it looks like nobody else in the world has found it until NetSPI has. The result of that is that when you work with NetSPI for cloud security, you're not just getting a network tester that has done a little bit of reading around the cloud. You're not just getting an application tester that has heard of IAM credentials. You're getting a cloud security tester whose sole focus while they work at NetSPI every day of the week is to test cloud security. They start with a configuration review, but they have a lot of experience actually conducting the tests and the attacks that I've shared with you in this conversation. And as a result, when you ask them questions around how do we fix this? How do we architect this? Where did we go wrong? They'll be able to give you a real answer and real advice, as opposed to just pointing you at the standard guidance of a benchmark check or any kind of standard configuration review. The end result is that when you come to NetSPI, you'll have your problem solved, as opposed to just a little bit more visibility. If you'd like to learn a little bit more about what we do and put to the test some of the things that I've just said, you can find some of our blogs online, netspi.com/blog/technical, and then you'll find a few different ones. There's a couple highlighted on screen, and we'll share these slides with you so you can click the links directly. But you'll be able to see a little bit more about our research into Azure function apps. We've also looked at the Service Bus Power Platform component of the Power Platform that'll also demonstrate the level of detail that our teams go into. Not only that, but we've also released our own tooling called Microburst. You can find that available on GitHub, or you can just Google Microburst right now if you like, and you'll find it on the NetSPI GitHub public-facing side of things. To put in perspective how powerful Microburst is, it is at the point where Microsoft recognize it as a tool. We've worked with them and they've seen it in use, and they've been able to verify that people around the world are able to test and validate the security of their cloud environment, specifically using Microburst. To wrap it all up, we've also published a book, and I mentioned that a little bit earlier. You can find that online. We do have some copies internally as well, and you're very welcome to get in touch if you'd like to talk to us about our cloud testing. We can reference a few sections of it to demonstrate what we think is relevant for your environments if you happen to be using Azure. But that book is more than 300 pages of detailed analysis on cloud security, how to test it, right down to the individual commands that you can run. We've done that because it still only represents a small portion of the collective knowledge that we have at NetSPI, and yet it is so much better than most of what you'll see in other areas of cloud testing. The final part, if that isn't enough to convince you that we're in a good place to help you out, is that our head of cloud security research, Carl Fossan, has been involved in a couple of different DEF CON talks, the kind of talks that are delivered to some of the best and brightest in the security testing industry. And there were a couple of those from both this year and last year that you're able to find online. And you can listen to Carl and his expertise firsthand to decide if we're the kind of team that you'd like to work with. So we're almost at the end of today's session, so I'll wrap up with a few keynotes for you guys to take away. The main thing that I'd like you to take here is that configuration review alone is never going to be enough to keep you safe. It goes a long way to helping to determine if you've designed things in the right way, but unfortunately, there can be vulnerabilities that are simply not visible from configuration alone. That's why at NetSPI, we offer hands-on testing. We'll put your systems to the test with hackers that understand how to navigate a cloud environment, how to move laterally, what credentials look like, and how to use them to demonstrate the damage that they can have. We'd also recommend that you maintain an awareness of the shared responsibility model and use it to your advantage as an organization. There are some things that the shared responsibility model will never be able to take away from you. We'll always be responsible for handling who's allowed to access an application, which person is allowed to register an account, and that kind of thing. That's business logic for us as individuals and teams. But you can remove the need to look after things like physical security or operating systems and a whole host of other components that make IT security complex. If you use the shared responsibility model to your advantage, you can potentially save money and focus your security efforts on specific things that matter. And while you are focusing on security and the details, try and avoid secrets wherever you can. In most cloud platforms, when you need to provide something with permissions, you can do so directly using either managed identities or attached roles. There's various different terms used to describe those setups. But if you can, wherever possible, avoid creating static credentials that take the form of an access key or a secret key or a username and a password, and adding those into cloud platforms. Try to use the built-in security handling features, and as a result, you'll be able to be pretty confident that the only way an attacker can abuse that design is by abusing the code of the architecture itself. And most of the time, they're very hesitant to do that. Certainly as pen testers, we don't want to be manipulating production systems. And most attackers don't either, because their intention is to compromise everything, do things like deploying ransomware or other kind of attacks, compromise data. But if you've made sure that the only systems that can access your database or the only systems that can access Intune to control your devices are the specific functions and features that you've designed, rather than credentials that could be used from anywhere in the world, you'll massively increase your security while still enabling your business to operate the way that it currently does. The final part is a message you'll have heard many a time. Think about the principle of least privilege. If you absolutely need to create static credentials, then that does happen from time to time. But make sure that those credentials can only do what they absolutely need to do. If those credentials only need read access to a specific bit of data, that's the only access that they should provide. They shouldn't provide read access to all of your S3 buckets, to all of your data. They certainly shouldn't provide write access. There's no scenario where you should ever be providing credentials that just have global administrator attached to them. If you need to add a new global administrator, use the built-in mechanisms to create a user and attach certain permissions that they need to have, and where possible, use that just-in-time access as well. Most of all, if you've got any questions around this, please do feel free to ask those now while we wrap up the session for today. And if there's anything that comes up over the next few days or weeks as a result of this conversation, please do get in touch with the SecureLink team or the NetSPI team, and we'll be more than happy to help you secure cloud environments, both now and into the future. So for now, I'm going to pause for a few moments. We'll take a look at some of the questions that have come through, and we'll answer a few just before we wrap up the call today.
Thanks, Sam. Thanks, everyone, for attending this session. Thanks, Sam, for the valuable information about cloud security and penetration test. We have some questions, and we hope to have more. One of the questions mentioned that, are there any services or product that you would recommend it at NetSPI which are complementary to NetSPI cloud penetration testing?
Yeah, that's a good question. Thanks, Ahmed. So yes, is the short answer. The cloud covers a lot of different areas of IT as well as security. You've got your virtual machines and infrastructure, but you've also got applications. So while we do cover things like application testing and network testing and host reviews, one of the most common services that we actually see combined with cloud testing is our attack surface management platform. That platform is an automated way of keeping an eye on all of your different assets, both your on-premises assets that face the internet and your cloud assets that face the internet as well. What that means is that as your cloud environment grows and scales to meet the demands of your business, our attack surface management platform can automatically monitor it for you. It will tell you when there's a vulnerability that exists in that cloud environment that needs fixing. As long as we can see it, we'll tell you about it. It also provides a useful mechanism to know when you need some manual testing as well. If you've deployed a new application, ASM, our platform might say, this doesn't look quite right, but it might not have full visibility. That's the point where you can get in touch with us and we'll have a conversation around how do we add that last bit of visibility to help you keep things secure in the long term with a full picture of everything that you've got at risk.
Okay, thank you, Sam. Another question, is the instance metadata version 1 API still an issue in AWS today?
Yeah, that's a good reference to. So the metadata API is a mechanism that's used by, in this case, AWS especially, but Microsoft has one for Azure as well. It's designed to let you pull credentials for a system. So when I spoke about attaching roles or managed identities to systems, and we mentioned that EC2 setup where that pass role permission have been used to make that particular virtual machine an administrator. When you want to get those credentials, that's the system that you're using. The system will call the metadata API. The problem that the version 1 has is that you can call that just by making a simple web request to it. So what we have seen is if you host a website and use something like AWS or Azure and it's set up in this way, if there is a simple vulnerability in your website that lets somebody that's using the application send a single web request and get the response from that, maybe you allow your user to provide a URL that your application sends a notification to, or they provide a URL and your application goes and downloads a file or something from the URL they provide. If you've got any features like that and you're hosting it in the cloud, attackers have been able to point your application at the metadata API and just pull credentials, and they can then get them without any real access to your cloud environment. Through one application, they can pull them. The problem with version 1 is that just works. Version 2, which is now available if you configure it in AWS, requires that you add certain extra information to be able to pull those credentials. Because version 1 doesn't require those, though, it leaves quite a few applications vulnerable to that kind of attack. And if you're not sure about whether or not you're vulnerable to this, it's well worth considering a combination of application testing with our web application team, as well as some architecture review of your cloud environment, and that's where our cloud team can help as well. That combination will give the ability to understand, is my application at risk from this kind of attack? And then if somebody does manage to get into the cloud environment, what can they actually do with the access that I've given this particular system or this particular application?
Thank you for the clarification. We have another question here. How do you recommend organization maintaining a proactive and continuously improving approach to their cloud security posture following a penetration test?
Like that. We were talking about this at Black Hat. Maybe this was someone that came along to visit us at Black Hat recently. The key thing there in that particular question is the word proactive. Continuously is very important too, but proactive is what makes all the difference between successfully defending your organization and finding out too late that you have a problem. So the main thing that you should do is consider security at every stage in your cloud journey. You might be looking at the cloud and not using it yet, planning to move your organization to it. You might have built your entire organization in the cloud, but at every step along the way, every time somebody wants to change a component, add a new component, consider the security implications, and the proactive part is to test them as well. That combination of continuously considering things and then testing them proactively will get you to the point where you'll know about a security issue almost always before the attackers do. And in doing that, you'll be able to avoid a scenario occurring where somebody's been able to attack you and do some damage via a mechanism that you didn't know existed.
Thanks again. We have two more questions, and I think the time is over, but let we try to answer them in brief. Do you find a significant difference in security challenges among various cloud service provider? Example, AWS, Azure, Google Cloud.
So yeah, interesting take. So the different platforms have some very similar approaches to security. There are some differences as well. I know we're short on time, so I won't go into a lot of detail on this one. But what I will say is that all of the different platforms offer the same potential to secure your environments. They just do it in different ways. So what's important to understand is how can you go about understanding the different services and mechanisms that they provide for security and ensuring that you're applying those defaults so that when your team are using the cloud by default, things are in a secure way, and then they'll need to ask you to disable bits of security or provide specific permissions.
Okay, the last question, you mentioned a book on Azure Cloud testing. Thank you for the link. Are there other books you would recommend as we learn more about cloud security?
There are quite a few good resources out there for cloud security. As much as I am a little biased, I do think that the content we've produced at NetSPI in that particular Azure book is excellent. In fact, we had someone join us at Black Hat who said that it was the best resource that they'd actually found for Azure. But if you're interested in more of a bigger picture as well, I'd actually lean towards other resources than books. There are some other books out there, but the most useful things that I've found are to make use of the resources online. So both Microsoft and Amazon offer various bits of training that are security focused for the cloud. In fact, they offer security architect certifications, and a lot of the training available for those comes free. It depends on what you're going for. But if you're aiming to just understand security in the cloud at a general level to help you make good decisions, what you should be looking at is how do real people do it in the real world. And those security architect training materials are usually the quickest and most efficient way to get the details that you need to make sure you can make informed decisions. And the only other thing I would say is get hands-on with it as well. Some of the theory stuff that you can find is really valuable, but if you can get hands-on with the cloud environments, which often offer trials and temporary access at no cost, that's a really good way of understanding, oh, I've set it up and it works, but it actually isn't secure at all. So hands-on experience, some really great resources from the cloud providers themselves. And if you do fancy reading a book, I don't think it gets much better than what we've provided here at NetSPI.
Thank you, Sam. I think we do not have more question. I would like again to thank the attendees for their time to attend this session. Hope you have got valuable information and hope to contact with you soon and looking for an opportunities for web penetration testing, cloud penetration testing. Thank you, Sam, for your time and for your valuable information and clarification regarding today webinar. I think we can end up the session now. Thanks, everyone. Thank you.
Thank you very much. Thank you for joining us.